Okay, we're going to go ahead and get started. Good afternoon, everyone. Hope you all enjoyed the tours this morning. This is Bruce Manclark. A lot of you know who he is because he's been around a long time training on duct testing. He is the co-owner of Delta T, an energy services company in Washington, actually Goldendale, so it's not too far from here. He has worked in the energy conservation field for over 25 years, and he is a proponent of pressure diagnostics, performance testing, and contractor training. Under Bruce's direction, Delta T crews have rehabilitated more than 10,000 duct systems for focusing on tightness, balancing, and correct fan performance. And today he actually has a mock version of a piece of duct work, and he's going to go through and show you how exactly his duct system works.
Thank you.
Bruce.
Is this sound level okay? By the way, my furnace is eligible for the federal tax credit. How many people have seen a duct leakage test performed? How many have actually done one? That's good. Okay, I'm glad we brought this. The presentation length is 60 minutes. If you have questions, just blurt them out or raise your hand. If I do reserve the right to say, can we talk later, just in case we run against the 60-minute time period. Let's just say you're a contractor and somebody comes up to you and says, your duct leakage can't be more than 12% of the floor area at 50 rascals. I mean, it's a funny language. They don't know what you're talking about the first time you introduce this to them at all. Already, code requires 2 pressure tests. Hopefully, in the areas that you work, you're requiring these tests. We want to make sure that we don't have gas leaks, and we want to make sure that we don't have plumbing leaks. The nice thing about those is we don't allow any leakage in that. So we just say that that needle and that pressure gauge can't change at all. Ducts are a little different. All ducts leak, even the really tight ones. And so we have to come up with a flow. If I stood up here and said that I'm going to pressurize this duct system to 1 psi using water, and I'm only going to be allowed 5 gallons a minute of leakage at 1 psi, besides making an entire mess of everything, you'd all have a pretty good physical intuitive idea what I was talking about. When we say CFM at 25 pascals or 0.1 inches water column, it's the same thing. We're talking about a flow rate at a given pressure. This is a graph from Washington State Energy, WSU. And real basically, and we'll go ahead and do this test in just a minute, what we're doing is we've got our duct blaster as a brand name, so we'll call it our duct pressurizing jig. And we've got a really big manometer right here. And what we do is we tape off all the intentional holes. And the intentional holes are the registers and grills. And we pressurize it. In this case, we pressurize it to 50. And then we see what our fan pressure is. And because we're using a smart manometer, we can then tell how many CFM. So this is the part where hopefully I will not crash my computer system. And we will... Fingers crossed. We have our own world's biggest manometer. And this actually will read this manometer directly. Kind of cool. I didn't write the software, trust me. What we've done here is we have 2 registers in the whole house because we got kind of stretched on the HVAC budget. And we've taped one off. And this is the one our pressure tap is in. And I used the foam block on this one. And this is supposed to be our U-Haul air handler box right here. It's green. It's a recyclable furnace. And this is lovingly called the snorkel. And it fits to the fan. And we're not going to get into the nitty-gritty of how to do this. But at the center of this, we have this pressure sensing ring. So what I'm going to do here, and just keep your eye on one of the giant manometers and your fingers crossed, and we're going to see what the leakage is at This is a really common mistake when you test duct leakage, is not to connect the hoses. Did that on purpose. So I'm going to bring this up to 25 on the left-hand side, and because I've programmed this ultra-smart manometer, it's going to tell us what the leakage is. So we're almost, okay, I'm not going to argue over a couple of tenths of a Pascal here. We'll turn it down just a little bit. So roughly speaking, our duct system here has about 50 CFM at 25 pascals. Here's the really interesting thing. I was in Idaho 2 weeks ago, and we saw a 2,000 square foot house that had a total of 36 CFM. And this box is actually pretty taped together, and we didn't go out of our way to make holes. So again, it's a flow rate. I'm saying when I pressurize the entire duct system to 25 pascals, it leaks 52 CFM. So when we talk about this code, keep that 52 number in your head, okay? Anybody have any real quick questions about this duct leakage test and how it sets up or anything like that? Good, because we're going to spend about 10 minutes on how well-meaning people can do little things that can get different test results. Now, let's see if we can get back to the other program. So, this is, to me, a really encouraging picture over here. And this is a serious guy, Apollo Heat out of Kennewick, Washington. Got his hard hat on and a safety vest. And he's going through his houses, and every house, he's got a number he's got to hit. The other picture is one of David Hale's on a finished house. David works for Washington State University. And these are typical ways you hook up. David's hooking up to the largest return grill, and this individual is actually hooking up to the furnace cabinet itself. There's two tests that are in the new code. One is called the total test, and that's just the one we did there. Regardless of where the duct is located, whether it's in an attic, a crawl space, a garage, or the house, or between floors, or any place else, it's going to see that hole. The other test it talks about, which is sort of hard to understand until you see it a few times, is called the leakage to outdoors. And the disadvantage of this test is you need two pieces of equipment. You need this duct tester here, and you also need a blower door. And the first time you see this test, it's a little confusing. There's like a couple manometers and tubes running all around and fans all over the place and lots of ways to mess it up. But the way it works is you need two things for a leak. You have to have a hole and you have to have a pressure difference. So what the blower door does is it pressurizes the house to 25 pascals. And if you pressurize the ducts to 25 pascals, and if you have a leaky duct inside the house, how much air will go through that hole? 0. That's why you sit in the front of the class. Yeah, 0 is the right answer. So it's kind of a cool trick. Disadvantage, you need two pieces of equipment. And this is sort of the test shown schematically. The big difference, hopefully this is, hey, the laser, it works. So this is the blower door pressurizing the house to 50, which is the same pressure that you're going to bring the ducts. So that's how the duct leakage outside test works. So here is this highly schematic, and this is one thing I always want to tell people. So when you're doing a duct blaster test, and if I keep saying 50 pascals, it's because here in the Northwest, for whatever reasons, we test everything at 50 pascals and not 25. The reason that is because we're twice as good. No, that's not it at all. The reason, I don't know why it is. It doesn't matter whether you do it at 25 or 50. But when you do a duct blaster test, you are getting everywhere in the duct system to your test pressure. This is really different than when the ducts are at operating condition. You might see 125 pascals right underneath the furnace on the supply side. And you might only see something like, what's the number? 2. You might only see 2 pascals. Your duct blaster doesn't care. If you got a hole this big at the boot and this big at the air handler, it will give it equal weight. In terms of saving energy and money, if you're giving direction on where to get the most exact about duct sealing, the closer you are to the fan, the more important it is to seal that hole well. Just remember, duct blasters don't care where that leak is. The energy does. So our crews had a motto, boots for show and plenums for dough. When you're trying to save money, focus on the plenum. You've sealed some ducts in your life, haven't you? You have that sick duct sealing sense of humor about you. I sense that. The further you are away, the less the pressure is. The greater the pressure, the more important it is to seal that hole in a way that will last forever and not leak at all. And this is just another highly stylistic chart that, again, this one's in inches of water column. You know, most of you are probably looking at this one, aren't you? Maybe I should move over here. What it just says is the closer you are to the fan, the higher the pressure. So the 2009 Energy Conservation Code, at the rough end, did I skip one? I have a feeling I don't know how to go backwards with this. Oh no, I've got that screen. You'll stop. Sorry for the technical difficulties. Okay, sorry about that. They give you 2 options. One is the post-construction test, and one is at rough end. At post-construction, they are allowed up to 8 CFM per 100 square feet at 25 pascals or 1-inch water column. That's leakage to outside. That's the one with the blower door. The other way to express that is 8% of the floor area. Total leakage, you're allowed to go up to 12 CFM. At the rough end test, that's before the sheetrock goes up, so we can't use a blower door, you're allowed 6 CFM. And with the air handler in place, and if the air handler is not in place, you're allowed 4 CFM. Exception: if the air handler and ducts are inside the conditioned space, no duct leakage test is required. One of my secret hopes out of this code is that people find duct testing so disgusting and so discouraging and so laborious that they start to put their ducts inside so they don't have to do it. It's really a much better answer. How does this compare? Well, in the Northwest, we have a 6% standard at 50 pascals, because we're twice as good, for the floor area. PTCS, which is Performance Tested Comfort System, which is a program that the local utilities use for retrofit duct sealing. The duct sealer has to get it to 10% of the floor area. That's to outside. Yeah. Conditioned space. That's a much better definition. It is conditioned space. Thank you. So I was bored, and so I went through and I tried to gather all the specs that I could lay my hands on within 2 hours. And because some of them were at 50 and some of them were at 25, I equated them all back to 25. So Washington State in 2010 is going to institute a 6% at rough-in and a 4% at rough-in with no air handler. The Northwest Energy Star comes down to, call it 4% at 25. These homes in Idaho I was inspecting would be 1.8. So this is give our uniform 2,000 square foot house what the maximum leakage is you could have and pass these standards. Does one of them sort of jump out at you? That's a big number. And that's at 25. I could install a duct system tomorrow, and as long as I didn't feel inclined to use building cavities, and it was a flex duct system, I wouldn't have to put tape or mastic, and I could pass this result. This is an easy standard to meet, as long as you don't use building cavities. Your builders and your HVAC contractors, if they say this is undoable, and there's no chases and building cavities and other silly stuff we pretend that carries air, they're not even trying. So 240 is pretty generous. Again, I just got back from Idaho, where in reality some of the homes we were testing were beyond the limits of the duct blaster to test in terms of tightness. So it's achievable, it's doable. Just don't use building cavities. Okay, so this is really an important way to minimize differences in duct leakage test. Have everybody test the same way. There's different ways. Some people like to depressurize. Some people like to pressurize. Some people like to tape. Some people like to use foam blocks. They all can result in differences. Don't make mistakes. The total test is harder to make a mistake than the leakage to outside test. And recognize that some homes are just squirrely. If you have a tall home with lots of interior duct leakage, it's squirrely. You've done duct leakage testing. I recognize a couple of faces over there that have done duct leakage testing. If we all went out to a 2.5-story home with a lot of interior duct leakage, we could get really different numbers on that house. Know what you're going to do with toe kicks. This is where the toe kick comes up, and you know this guy, rather than heating the soap underneath the the laundry, there he's deciding to actually get the air to come out the front. If you use a square duct, you got to cut a round hole, and if you use a round hole, you got to cut. Yeah, you got to do it backwards. So imagine.
That's not permitted by code, because code says supply ducts have real
So here's my point. Let's just say I go out to this house and it's at finish, and I seal my register off here. Am I measuring the leakage of the cabinet and any plumbing in that wall? And that gap between the boot and there? Probably. I urge you to carry round foam, or whoever's doing this, is to attempt to seal that off at the floor. Rough-in testing is a lot easier to do. You can get the stuff. But toe kicks, you can get big numbers if you tape off the front. Whether to use tape or whether to use foam blocks. In new construction with wet sawdust, it's really hard to get your tape to stick. And so we use a lot of foam blocks. And if I can pass anything on to you, it should be put your foam blocks inside of trash compactor bags. I don't know what kind of plastic they make, but that plastic never rips. And you also don't leave them behind because there's this big tail of white plastic. But imagine we have one person that went out and they taped over the register to the floor. And there was a gap between the floor and the register, or a gap between the sheetrock and the ceiling and the register. And the other person used a foam block. That can result in 50 CFM to 75 CFM in the average house. So I think you should all at least sort of, do your best to test the same way. Sorry, guys. The Energy Conservatory, and there's other people that make this, but they all make really good training manuals. And there's training available. And if you're one of those rare individuals that yes, sir.
Backslide.
No, I can't. Oh, okay. Yeah, okay. No, I'm just saying that, no, I'm saying it's important. Especially in the ceiling, if you live in a hot, humid climate and there's a gap between that, then you can have all kinds of moisture problems. I'm just saying it's a difference in test results sometimes. I'm saying seal it. Good point, thank you. If you're one of those individuals that can take this manual and go do a duct leakage test, good for you. Training is pretty essential. Most people in the trades are hands-on learners. Period. I once went to a duct sealing class where we just headed right into a crawl space. And this was a bad crawl space. And the guy next to me goes, when they said training, I thought I was going to have to sit in a class all day. So he would rather be in a wet, damp crawl space learning how to use a duct blaster than he would sitting in a chair. So your program has to be supported by training. Sensor ring care and feeding. This is actually what's at the center of the duct blaster. It can get damaged. Some people like to use the chemical fog, and it actually plugs the sensor rings, and sometimes the hoses can also. For whatever reason, people, I don't know why, they like to put the rings on backwards, but they do. They're supposed to face in, not outie. The way I get people to remember that is innies, not outies. The bad news is you'll get a number. That was my dog chewing my pressure hose. Hoses do develop leaks. Okay, so where do we put the pressure tap? I don't know. I like to put it some distance away from my fan. On new construction, it shouldn't matter too much in most cases because the duct system should be tight enough that it doesn't matter. However, if you put your pressure tap behind, let's just say we have a teddy bear here, or a pile of wet sawdust, or leftover deli sandwiches, or a closed damper, or it's full of water. If I put my pressure tap there, I might crank and crank and crank, and my pressure tap might not ever see anything. I think it's a good idea to go around and test the pressure in a few places. How many people have ever heard of Bob Davis and Ecotope in Seattle? Bob's a pretty careful guy, does careful research. And he's a good friend, so I get to tell a story. He tested his house 3 times, and he got a different result than the contractor 3 times. And this is a good contractor. Contractor was pretty peeved. Bob was putting his pressure tap downstream from that rat nest. And the contractor was picking another register that didn't have a rat nest. Post-testing duct leakage happens. Do you guys know what plumbers call flex duct? Knee pads. Thanks. So, hey, I got to put a drain here. The one on the left was caused by somebody putting a screw through the interior liner of a flex duct, which is against the manufacturer's warranty advice. So obviously, if you put your pressure tap in either one of those registers, you would think you had an infinitely leaky duct system, when in reality, you just had something a plumber or electrician damaged. This company right here uses 2 different kinds of furnaces, and they've made a sheet metal jig that they just take off the blower door compartment, put that on. Saves about 10 minutes of futzing around with tape and cardboard. It goes pretty fast. There's a partial answer to your question. Yeah, it is important to seal. Also keeps the mice out of the cupboards, which, is another nice thing to do. Okay, so how do we get ducts tight? This is where you laugh, okay? If it's mostly sheet metal, it's been my experience, I need to use 4 or 5 gallons. Mastic is cheap, labor's not. Despite what your HVAC contractors might tell you, mastic is about $12 a gallon. What's expensive is to go back and fix it. This is so beautiful, it almost makes me cry when I see it. This thing is sealed so well. The flexible part on an elbow is called a gore. I guess it comes from armor, the flexible part. That's what I'm told. Anyway, gores leak a lot. Think about it. They're made to move, so it's not, they're going to leak some. It's screwed together. This is my advertisement for mastic. What's the biggest gap a roll of 2.5-inch tape can cover? You're fired. Usually somebody says 2 1/4, and this one guy goes, infinite. I can just keep lapping it over. And it will pass. When you use mastic, you actually have to screw everything together before you seal it. When you use tape, you don't have to do that. You can sort of make entire houses out of tape. Tape is not a fastener, despite what some people think. And tape works best where it matters the least. Tape works well when the 2 pieces of things you're trying to seal are in the same plane. If you're trying to seal a takeoff like this, how are you going to put the tape to cover that? It's not going to work very well. Mastic's cheaper, faster, and better. And once you get... this is from a jurisdiction that will remain nameless. They required all their fittings be sealed with mastic. Can somebody tell me what the effective difference is between those 2 pictures? One passed code and the other didn't. Because somebody said, yeah, they put mastic on it. This is finger painting. It didn't seal anything, and we're not even talking about the gores. They got the butt joints, but they forgot the gores. Gores leak. Gores leak about, on an 8-inch elbow, that's about 5 CFM leakage right there. Can anybody tell that the person holding this fitting up is an experienced HVAC installer? And how can they tell? No fingernail, that's right. Or for cutting edge sheet metal. But what the nice thing about this is a beaded collar. People should not be putting screws through flex duct liner. It says not to right on the package. And this is the answer. They're beaded collars. It fits, and the Panduit strap fits on the top side of it. When people are using the tensioning ties, they come with a $26 tool that get that tension ties really tight. If they're just hand tightening it, it doesn't work. This guy didn't have the tool, I guess, because I could put my hand right underneath it. This was too thin to win. This was a 2-year-old job. These pictures didn't show up very well, but the mastic had already cracked. It should be about as thick as a nickel for it not to crack. It's cheap. I hate to see it put on with paint brushes because people think they're painting. They're not painting, they're plugging. Plug don't paint, thick as a nickel. There's the executive summary of duct sealing right there. So this was one hot summer day in Albany, and there was this young person sitting listening to the worst music I'd ever heard in my life, sitting in a lawn chair in a garage, and before him were boxes and boxes of sheet metal fittings and 5-gallon drums of duct mastic. And his job was to seal all the parts before the install crew showed up the next day, because they could get it done faster. They didn't have to stop and seal. Good idea. Sometimes you can seal the hole from the inside. You know, this is looking down on the base can that the furnace is going to set on. This guy just sealed it before he put the furnace in from the inside. It's okay to seal ducts from the inside. Nothing wrong with it. Okay, How are we doing on time? Got half hour. Any questions?
Way back at the beginning about air leaks nearer the plant versus air leaks further down. I understand why they leak more near the plant, but once you plug that leak, doesn't the same amount of pressure move up to the end?
To a degree, but it's not gonna compensate. You'll always have much higher pressure here than here. Yeah, that's. Does any other questions? That's a good question. Yeah.
Before we leave, can you go over, run down the different costs to purchase the equipment, acquire it? Yes. Before we leave today, can you run down the costs of this? Acquiring the different test equipment.
Let's just do it right now.
Okay.
Okay. There's 3 or 4 I think there's at least 2 there's 3 manufacturers. There's Minneapolis Blower Door, the Energy Conservatory. There's Retrotech and Infotech. Those are the 3 companies that manufacture those devices. The duct blaster, the duct pressurization jig is probably about $1,400 now. And the really fancy manometers, another $700. Any other questions?
There was a delay on the equipment because
And there's a delay on the equipment right now. Yeah, it's down to 6. Although Retrotech tells me they're not delayed right now. Yes, ma'am. You bet. Yeah. That's my delaying tactic when I think of an answer. Any other questions? Yes, sir.
Yeah, what's a typical cost to a builder to have? What's a typical cost for a duct leakage test in a typical residence?
Just the test, not the sealing?
Well, why don't you break it down? There's the test, and then there's the remedial action for sealing, and is there anything else?
If the HVAC contractor doesn't want to seal it, the price is $1,000. Okay. In the Energy Star program, we have seen the price sort of just get rolled into because that's how they do it now. I can tell you from my experience, and if I'm using tape now and I think I'm sealing, I might experience a price drop by using mastic. So I would, it depends what state the contractor's at. I'm going to say they should be able to do all the required sealing in 4 or 5 hours pretty easily at the high end. Mark, do you have any estimates on that? About the same? 0? 0 or my answer is right?
your answer is perfect.
Okay. And then the test itself, if the HVAC contractor is doing it, they're already on site, right? And if they got the foam blocks in the big gunny sack, it doesn't take that long to seal off. If somebody has to come in after them and find all the registers and remove the toe kick and futz with the return and all that other stuff and make the separate trip out, that's when the cost for testing can get up there.
Is this residential application?
The code I'm referring to is all residential, yes, but you can do the same thing on commercial. Absolutely, you can.
So, and the reason I ask is because earlier you said that leaks inside conditioned spaces really didn't matter.
Yeah, leaks, unless they're ginormous leaks, right? Small diffuse leaks inside the conditioned space of the house don't have an energy impact. They're leaking to the conditioned space. They're like little tiny diffusers, if you will. It's when they leak into the attics and crawl spaces and garages that there's an energy penalty associated with it.
Well, in a commercial building, if you had something more than a small leak, it could affect
Yes.
temperature readings.
Yes, absolutely. When they get big enough to actually affect delivered airflow to zones, then that can matter a bunch. Absolutely. You should have no disconnects. Regardless if they're inside or outside, they shouldn't be disconnected. This is a picture of the This shows you what a sick individual I am. I went to Paris, France, and took one picture. And it was of ductwork. This is the Georges Pompidou Museum of Modern Art. And I used to think, aha, those funny French mechanical engineers. But actually it was a British architect getting even with the French. Because they put all the mechanicals on the outside of the structure. And you can go, man, how goofy is that? So most of you that have been outside today recognize that it's hot outside. Is it hotter in the front yard or hotter in my attic today? I mean, it might be smarter to put your ducts there than in an attic. It's not quite so hostile. So you can look at this, but this is sort of how we build our homes. I cannot read the intent of those who write code, but I can guess at it. And I think one of the intent might be, if we don't require they test ducts, if they put them in the inside, maybe they'll put them on the inside. If I do a perfect job of sealing the duct system, use R8, everything else, on a cold or a hot day, I still got about a 20% energy penalty, just for the right to put them in my crawl space or my attic. Once you put them inside, it's like free 20%. When you say ducts on the inside, this is what people think of. And you try to pass it off as Euro design or something, right? That's just Euro design. No, they don't have to look like that at all. This is Quadrant, and Quadrant's the biggest builder in Washington State. They build all their two-story homes with web trusses. Their HVAC installer, Wade, he gave a talk at Affordable Comfort here in Portland. Did you get to hear it, Dave? I wish I could just have this guy follow in. It was sort of like, we like ducts on the inside. We get to stand in ladders. We don't have to roll in water. Our guys know their work's going to be looked at by the other trades, so they do a better job. Our jobs come in close to our predicted time allotment 95% of the time. When we put them in crawl spaces and attics and garages, that doesn't happen. Our installers should last 10 years longer working on ladders than crawling in crawl spaces. And guess what? Their plumber likes it. Their electrician likes it. Web trusses on two-story homes are a great way to get ducts on the inside of the house. It's a huge energy benefit.
How valuable is it to test the duct that's on the inside?
The way I read the proposed code, and correct me if I'm wrong.
Not according to the code, according to you, is it an efficiency measure to test it?
No. If I can see there's no disconnects, and I can see that space between the floor is well insulated and well air sealed, I'm not going to test it. Mark? Maybe?
I think you have to test it first. I think testing is one of the only ways to keep assuring that things are getting done. For a while.
For a while. Okay. This is, anybody from Idaho? This was some attics in Boise, Idaho. On a day similar to today, actually not quite this hot. And I think there's 6 different attics in here. And you can see that, how many people have ever worked in attics on hot days? It's pretty miserable work. And yeah, it can get to 140 degrees. And yeah, your head's away from a roof deck that's 160 degrees. And it's miserable. And I couldn't even imagine it in a humid climate. So bear with me for a while. Okay, this kind of focus in on here for a while. The yellow line is the attic temperature, and yeah, it's peaking late afternoon. The blue line is the temperature of the air going into the return grill in the hallway. The purple is the temperature of the air before it hits the evaporator coil in the garage 35 feet away. Wow. And this was not like a really leaky return. And it had an R4 worth of insulation on it. I mean, we're really raising that. I mean, think about it. When you put ducts in a hot attic, what have you done? You made a radiator. Getting ducts out of those nasty, unconditioned places is a really good thing to do. Here's some conclusions. Putting the ducts inside is the best and maybe the cheapest answer. We have a builder in Idaho who's actually scratching his head that he might save money by going to web trusses because the bids from the electricians and the plumber and the HVAC is coming back cheaper. My opinion, tape is kind of a Band-Aid. It lasts for a while and doesn't heal anything, so maybe the analogy is not real good. Try for consistent testing procedures. It matters how you test. If you want people to get the same results, maybe, imagine we're 4 years down the road and there's 5 testing companies where you live. One guy's getting all the work because his name's Easy Joe. He passes everything. I call this troublemaker over here, and he fails half of my jobs. And it might just be how they set up the testing jig. Yeah.
So there is no standards for
Yeah, this is a really good question. And we got some experienced testers in here. Don't be bashful on supplementing my answer. Could you ask the question again, please?
Yeah, wondering if there are any standards like SMACNA or ASHRAE or whatever on testing.
It's amazing. There's a bunch of standards. We'll call them protocols. There are a lot of protocols on how to do this, but they're really vague on where to put the pressure tap. They're really vague on, do you tape off? Do you put a foam boot on? Do I put the testing jig always on the air handler? Can I use it at the return? So if you want the same number, you should all do it the same way.
Well, one more. So if this is a code requirement?
It's part of the 2009 International Energy Code, yes.
But they have no, it just seems odd that there's not if it's a code requirement, why wouldn't there be a standard for the...
I haven't dived into the code enough to know if they've got a procedure in there for testing. Is there? Yeah, and that's sort of why I say training is a really essential part of this, because that's something training could address. Yes, sir.
Can this be tested in a negative state without the blower door?
Yes, you can depressurize. The way I read the code, you can pressurize or depressurize. It just says you have to create a pressure difference.
Without the blower door, you can still make a negative?
Yes, you can depressurize as compared to pressurizing the ducts, yes. And the nice thing about that is that if you're taping, it's easier to keep the tape on the registers when it's depressurized.
You can do this without a lower door, but you can't test outside.
Was that the better answer to your question?
Yeah.
If you want leakage to outside, you have to have a blower door. With or without the blower door, you can pressurize the ducts or depressurize the ducts. Thank you.
What about testing? Your only concern is leakage to the outside, not using the blower door and sealing the line or anything.
That was called the blower door subtraction method, and sometimes you actually come up with negative duct leakage doing that. We've tried that, and boy, did we confuse ourselves. Sometimes it works. This is much more precise.
I would comment on that. That it's kind of like, I'd like you to, the blower door is the wrong tool. I'd like you to measure the thickness of this business card, but I'm going to give you a yardstick. It's better than no tool, but it's not the right tool.
Yeah.
But, I was going to comment, you're asking about consistency, and I don't know that it's consistently right or wrong, but at least it's consistent.
Right.
That we typically, we always connect at a return, and we always pick, well, I looked it up, should it be the nearest supply or the farthest supply? But our consistent answer is the easiest supply to get to, which is usually a supply in the room that's where your return is. And it has to go through the whole return duct, through the air handler, out into the supply plenum, and then out into the trunk. So I think unless, and this is what I read in the manual, unless it's ridiculously leaky, you're going to get about the same answer.
Yeah, the bigger ones are, do you take the filter in or out when you do it? The bigger ones are, did you tape or did you use the foam? Another no-no is to put the duct blaster directly on top of a supply register. The back pressure against the fan really makes it go crazy.
Well, the other thing too is that the flow, I mean, if it's a reasonably tight duct system, or let's just say you're trying to measure a flow in the neighborhood of 50 to 100 CFM, the pressure drop across the filter, if it's a 1-inch filter and it's, has been changed within the last 10 years.
The tighter we get our duct systems, the more similar our test results should be. Could you say that really loud, or someone get a mic over here, please?
Where are they?
Right here.
I'm sorry, I couldn't see them.
My question is, are you using the leakage to outside test just when you have ductwork that's running through unconditioned spaces?
That would be, okay, am I using the leakage to outside only when I have ducts running through unconditioned space? Crawl spaces and attics. If all my ducts are in the garage, crawl space, and attics, theoretically the leakage to outside and the total leakage should be the same because all the ducts are outside. So the time it gives you more precision and might be worthy of the investment of time is if I have ducts inside and outside. That's when it lets you know a little more.
Do you have a test procedure that you think should be in the code?
I have helped write several. Yeah.
Can you name it?
It's called the Manclark test. No. Yeah. Yeah. It's. I come at it from the bias of an HVAC contractor. So it's what's easiest for me at rough in. Okay. And I like to go in at the air handler because it's in the middle of the system.
You don't have a big test.
I do. If you want one, I'll be glad to send it to you.
Second question, if you just condition the attic, is that as good as bring the duct to door?
If you do a good job of it, absolutely. Sir.
Sorry, is there some easy way to find the spots of leakage?
Yeah, and one of the ways that we found really good to train new crews was to put a duct system together on a shop floor. Like, okay, guys, here's a bunch of spare parts. Go put a duct system together on it. Hook up the duct blaster. Go down to Walmart the day after Halloween and buy a fog machine for $10. They last just as long as the ones you buy from the rock video sites. And you tape off all the registers, and they start to see where the leaks are. And it is really educational. And what's nice about that is crews need to learn sort of like, oh, I did this and the CFM went down 10. I did this and nothing happened. I did this and the CFM went down 50.
So you mean the smoke test or something?
Yeah, smoke test.
You mentioned that tape is a Band-Aid of the HVAC industry.
My opinion.
Could you clarify the applicability of UL 181?
Again, just because, in my view, tape allows for poor workmanship. And the one place that I really don't like to see tape is when you have two pieces of metal coming together. Two pieces of metal come like this, and you clean it and use all the instructions, tape will probably work fine. This sort of stuff, it doesn't work very well.
Is it clean? That's
The clean. Yeah, and my best advice for applying mastic is plug, don't paint, and thick as a nickel. You don't want to say, I see these like 6'4" burly guys with, the ends of their fingers cut off by sheet metal, Ooh, that mastic is icky. Oh, come on. Put a glove on or whatever. It's cheaper, faster, longer life than tape is. And it's strange. So the painting mentality usually gets it on too thin. And meeting the 2009 duct tightness level is really easy. Your guys shouldn't be out there complaining. As long as they don't try to transport air in building cavities, they'll be able to meet that 12% standard. That's it for slides. If you got questions, or I don't know, what time do I have? 10 minutes. If somebody wants to ask questions or play with the duct blaster or whatever, fire away.
Well, we've
We've, from Minneapolis, St. Paul, and Gary Nelson, who I worked with at the Energy Office about 15 years ago or so, when he left and formed Energy Conservatory. Pretty good guy. People should get over to his shop.
Yeah.
It's a really good plant over there. And the issue is, during the summer, all the ducts are inside the house, okay? During the summer, homeowners call, they say, can't cool that second floor, and had my HVAC guy call him. He put a duct booster in, put a booster fan in, and it helped a little bit, but still is a problem. And what we have told him is you got leaky returns in your basement. And the leaky returns in the basement is putting negative pressure on the basement and sucking all the heat, all the coolness out of the first floor registered right back down into the basement.
And those are really leaky returns. Those are probably panned over. And I need to make a better point about this. Small, diffuse interior leakage won't swamp you. Big interior leakage can kill comfort, can cause condensation problems, backdrafting, and everything else. So your point's well taken. Thank you.
Bruce? Pam, back here. Could you address the duct testing equipment that's a lot more expensive and also cost for the ones that were after you do the duct testing, and also seals those areas where it's performing that analysis? One of them is aerosol, the product
Aeroseal?
Aeroseal.
Aeroseal is a product that's now owned by Carrier, which is now owned by United Technologies or somebody like that.
There's a couple other ones out there too. But
is there? I'm only familiar. So there's another aerosol product out there now.
Yeah.
They work. I know there's one in the Tri-Cities. It's generally a franchise deal. But if you put together the duct system with no big leaks, they can come in, tape everything off, and they blow in a heated aerosol, and that aerosol is sticky, like bubble gum, because it's the same base as bubble gum, I'm told. So you have all these little atomized sticky particles cruising down, and as soon as they see a hole, the pressure difference takes them out the hole. Well, they're sticky, so they stick to the edge, and they keep sticking to the edge and sticking to the edge. So the system can get duct systems really, really tight. I know somebody in the Bakersfield area in California, when they're building homes, one guy could do 5 homes a day using that process, and the numbers were essentially, you'd run it till you got to like 5 or 10 or some ridiculous number. No, it can do a really good number on a system. Thank you for bringing that up.
You made the point earlier in your slide that you thought that the code was relatively leaky. You didn't say it quite that way, but what should the
But I implied it. Didn't I?
You implied it. What should the code say? Pick a number.
Dave, will you leave the room? Okay, code is not Energy Star, okay? And this again, I'm speaking as Bruce Manclark, okay? And I realize the difficulty as code bodies of coming up with a number. It's not easy. It's easy for me to, the haha sort of thing, and only because no one, thank goodness, gives me the responsibility of picking that number. In the Energy Star program, it took a while to get to 6%. And only because we had verifiers that were willing to go out there and throw their weight around and insist on it. So we had an immediate feedback loop. I don't know what the feedback loop's going to look like in code. Okay? My personal opinion, 12%, if the only thing this code does is get rid of the use of building building cavities to transport air, it's done a really big thing. So having said all that, I think if I were to had to pick a number, I would have probably argued that somewhere between 8 or 10. Knowing that code is an Energy Star with all the nice feedback loops and the big carrot out there.
Question over here. Sorry. You haven't mentioned anything about multifamily housing, and I've had some folks argue to me that it just shouldn't apply and that there's no way to test multifamily housing. Can you comment at all on maybe what an appropriate method might be for testing a
So these are ducted multifamily systems?
Sure. I mean, what kind of pressure testing would you recommend for you know, a multifamily building of apartments?
Okay, they're ducted systems? Does each unit have its own system?
I don't know.
Thank you. There's no reason, if you had a multifamily with duct systems, you couldn't test it, especially using the total test. The blower door issue on multifamily does get complicated, but I think you should test them. Just agree on it, how you're going to do it.
Do you know why in the blower door test section of the code, the 09, it says duct shall not be sealed for the blower door test? Why would they not want the duct sealed? I think it was
because they want to include any leakage in the whole house number.
So it says duct, so no matter where the ducts inside the condition boundary should not be sealed for the blower door test. So
right. Or ducts outside shouldn't be sealed either. Yeah, if the ducts are truly inside, it won't matter. If the ducts are outside, it will matter.
So why would for a blower door test, the ducts are inside, why should they not be? It seems a little confusing in the code. Like, tell a heating contractor, I'm going to do a blower door test, don't seal the duct, come back later. And is it the duct openings or the ducts themselves?
Okay, I'm getting confused. Okay, so when you say sealed, do you mean like sealed with mastic or taped off for the test?
It says ducts sealed. It doesn't. It just says ducts shall not be sealed for the blower door test.
He means taped off. I think what they mean is taping them off during the test. Okay. Guys, I don't know code verbatim. I'm the duct mastic guy here. So. Okay. Thank you. Any other quick questions?
I had a quick question. We're working on upgrading the code in North Carolina, and I think because this is new, duct testing seems to be a new thing to a lot of the folks involved. They've brought up the question of should it be self-certification versus a third party coming in and testing. I just wanted to get your take on that. I don't know how to quite answer that
My
question.
personal take, I think both avenues should be open. One of the reasons I say that is one of the ways. How many people have dogs that they train, right? Yeah. I mean, it's sort of like, let's just say your dog just did something on the carpet you didn't like that dog to do, right? And 2 weeks later you hit it with a newspaper or whatever you do to punish it, right? If the contractor tests, the feedback loop's a lot shorter. We did this and failed back in the crawl space at 6:30 on Friday to fix it. You want that feedback loop as short as possible, and that's one reason I don't mind the contract. Having said that, if there's third-party QC, I'm all for that too.
Let's give Bruce a big round of applause.
Thank you.